In topic 27.1, we are going to talk about the ratio of perimeter and area of similar polygons and give a formal argument about them. So we'll be able to prove why they have that ratio. All right, so the first thing we're going to do is we're going to review perimeter, surface area, and volume. And I've got 4 different ones here that I would like for you to find the perimeter, surface area, and volume for. So the first one is a cube, and the perimeter, and when it says perimeter, it's talking about perimeter of the base. So the base is a square, and the side lengths are 3. So that would just be 3 plus 3 plus 3 plus 3, which is just 3 times 4. So this would be 12 inches. Okay. The surface area, if you'll remember, it is the side length squared. That gives you 1, and there's 6 of them. Okay, so here we just did 3 squared. Here we're going to do 6 times 3 squared. Okay, that's 9 times 6, which is 54. So that will give us 54 square inches. And then for volume, it's just S cubed, so that would be 3 cubed. And that are inches, we do have cubic inches. Okay. I'm going to go ahead and do this other cube since we're on cubes right now. So this would just be 4s. This is s squared times 6, and this is just s cubed. Okay. So the perimeter of the cube, the base, since one side is 6, then 6 times 4 is 24, so that's 24 inches. And then the surface area is 6 squared, which is 36, times 6, which gives us 216 square inches. And then 6 cubed would be also 216 cubic inches. Okay, remember this is area and this is volume. All right, now let's go to the cylinders. So perimeter of a cylinder is 2 pi r. That is your circumference. So if r is 3, then that's 6 pi. And in the directions, it tells you to leave them in terms of pi. All right, so for surface area, it is, if you'll remember, it is 2 times the base plus the perimeter times the height. And so we've just found the perimeter. The base is a circle, so it's going to be 3 squared times pi. So this will be 2 times 9 pi plus 6 pi is your perimeter times your height, which is 3. So this is 18 pi plus 18 pi, which gives us 36 pi, and that's square inches. And then for volume, it is area of the base times the height. So that's going to be pi times 3 squared, which we already found, times 3. So this is 9 times 3, so this is going to be 27 pi. And that's going to be cubic inches. All right, now let's do the same thing for this cylinder. So the perimeter, again, is 2 pi r, so that's going to be 12 pi inches. And then the surface area is 2 times the area of the base. And so this is the area of the base is 36 pi plus the perimeter times the height. So that's 36 pi, which is going to be 72 pi plus 72 pi, which gives us 144 pi, and that's square inches. And then for volume, it's area of the base times the height. So that's, we already found the area of the base was 36. That's 36 pi times the height, which is 6. So 36 times 6 gives us 216 pi cubic inches. All right, so now what we're going to do, it asks us for the ratio of the perimeters, the surface area, and the volume of the two cubes. So we're going to compare these right here, okay, for the cube first. So for the cube, the ratio of the perimeters is going to be 24 over 12, and 24 over 12 is equal to 2. So that's the ratio of the perimeters. Okay, now let's find the ratio of the area, which is your surface area. So we're going to do 216 over 54. And that gives us, let's see, oh, that gives us 4. Okay. And then we're going to do the volumes. So the ratio of volume is going to be 216 over 27, and that gives you 8. Now we're going to do the same thing with the cylinders. So we'll do ratio of the perimeter, which is going to be 12 pi over 6 pi, which gives us 2. Sorry, not 2 pi, because the pi's cancel. Then we're going to do the ratio of the surface areas, and that's 144 pi over 36 pi. Again, the pi's cancel, and that gives you 4. And then the ratio of the volume is 216 pi over 27 pi. And you guessed it, that's going to give you 8. So let's talk about this for a second. It says, how are the ratios related to the ratio of the dimensions? All right. Well, we noticed that in the cubes, we doubled the side.
Teachers, this is just a reminder that Thursday.
Okay. We just doubled the side length. Okay. And so you'll notice that the ratio of the perimeters also doubled. But then the areas became 4 times bigger, and then the volume became 8 times bigger. Well, let's think of this as what would be a number that you could raise to an exponent and get 4. So this would be 2 squared. And again, what is a number you can raise to an exponent to get 8? This would be 2 cubed. So do you think there's a coincidence that the area is squared, and when we talk about area, your units are squared, and the volume is cubed? Again, your units are cubed. So this is what we're going to talk about today, is the ratio of your surface areas and your volumes. All right, this just talks about a little bit how the relationship between surface area and volume play an important role with your cells, with diffusion, and if they don't have if they're not diffused, that doesn't diffuse the material at the proper rate, then it's going to become toxic. You'll get toxic waste buildup. All right, so if you'll remember, we talked about similar figures. They're similar if their sides are proportional and their angles are congruent. So again, they have to be the same figure, obviously. So these are not similar because you have a square and a pentagon, or a square and a rectangle. So those are not similar. They have to be the same shape. But the sides have to be proportional, and it has to have congruent angles. With solids, they are similar if this says their corresponding edges are proportional. With a prism or with a prism or a pyramid, that would be true. For cylinders and cones, it would be their dimensions, their radius and the height. So the dimensions would have to have the same proportion, the same scale factor for them to be similar. So these two are similar because the edges, so these edges double. So you can see that they all double. So this is 2 times bigger, so it has a scale factor of 2. Okay, the dimensions are 2 times bigger. Now what we're going to talk about is how the area is related to this and how the volume is related to this. It's eventually what we'll get to. Can you think of a figure that's has the similar base, but they're not similar solids? So here, if I look at this base, if I keep this as 5 and 2 and this is 10 and 4, those have similar bases. But what if I change this length of that edge to 50? Well, then these are not proportional. So even though that the bases are similar, the solids are not similar. And then here's another example of that. You have a cylinder with a radius of 2 and a height of 10, and then you have another cylinder with a radius of 1 and a height of 10. So the bases are similar because they're circles and all circles are similar, but because the heights don't have that same ratio, so the scale factor here is 1/2, or you could say it's 1 to 2, and so this would need to be 5 for it to be a similar solid. So these are not similar solids because their dimensions don't have the same ratio. Okay, I'm going to stop the video and then start a new one for this animation.